Our next speaker is our keynote speaker for the morning. It's a great pleasure for me to introduce Jean-Louis Briaud. He's the ASCE president for this year, American Society of Civil Engineers. He's also a distinguished professor of civil engineering and director of the National Geotechnical Experimentation Site at Texas A&M University. He holds the Buchanan Chair at Texas A&M University in civil engineering. He has completed a 3-year term at ASCE, on the board of ASCE, and the president of the Geo Institute. He's got 4 years of experience, 4 decades of experience at Texas A&M University. He's been a consultant on numerous projects, including embankments, oil tanks, dams, bridges, levees, foundations, and soil erosion. He's also written 2 books, published 300 articles. He's also received the Ralph Peck Award from ASCE and many other awards as well. So please help me welcome Jean-Louis Briaud.
Thank you. Let me get this. Yeah, thank you very much. Thank you, Habib. You know, I was listening to you, and this is pretty impressive. What I see. I'm really excited about those UTCs in the country, yeah, President-elect of ASCE. It's a great responsibility, and I wish to help you, among other things, to contribute to innovations and infrastructure. You know, ASCE is 150,000 members. It's the oldest engineering society in the country. We started around 1852, and we've done a lot of things, and one of which is to try to have an impact on infrastructure. And I want to discuss a little bit the report card. You've seen these things. This is a big undertaking. Actually, the first report card on infrastructure was started by Congress in 1988. ASCE picked up the idea in 1998, and we've been doing it every 4 years. It's a big undertaking. It costs money. Hundreds of people are working at it. We follow, you know, we have this D+ grade here. We follow a very strict procedure and methodology to evaluate the grades for each one of those infrastructure components. And if you, so we look at capacity, condition, funding, future needs, operation and maintenance, public safety, resilience, innovation. All this is documented on the website, and how we arrive at this D+ grade that we're facing. So over the years, the grade has not changed very much. Let me see if I can get my pointer to be, yeah. So this is the grade. Here you see we're at 68, 65, 65, 68, 68 over the last 20 years or so. And right here on this scale is the costs to improve the infrastructure in our country over a 10-year period. Then you're looking at the costs starting around 2.5 trillion for 10 years in 2000. And now we're at, because as we do not do so much, it becomes more costly, and we're now at about 4.6 trillion over 10 years. Now, it's not to say that, you know, Congress and the DOTs and the Federal Highway is doing a lot of things to improve our roadways and our bridges. And actually, out of those 4.6 trillion, about half of this is what the country is investing in infrastructure every year. So it's very significant, but it's not enough to be able to raise that grade to where we wish for it to be. Now, let's take a look at the, you know, our country's budget. Our expenses as a country is about $4 trillion a year. Our income is $3 trillion a year. So every year we have a deficit, and these are very rough numbers. You know, I'm a geotechnical engineer, so plus or minus 20% for me is bullseye. But so they don't hold those numbers as very precise, but it's to give you a sense. So we go into debt about $1 trillion every year, and we've accumulated that process over many years, and now we have a debt of about $22 trillion. Now remember, the 4.6 trillion that I showed in the previous slides was over 10 years. So per year, if you wish, it's $460 billion that we're talking about out of this income of $3 trillion. Now, the expenditures, the expenses, if you wish, is about 1 trillion for the Army, about 0.5 trillion as the interest on the debt. In other words, those 22 trillion, we have to borrow the money from ourselves, basically. And the return on investment, if you buy treasury bonds, for example, then you have to pay the interest, and $500 billion, which is not that much on 22 trillion, because right now interest rates are pretty low. But if interest rates go back up, then this part of our expenses is going to rise. So all this to say that there's a lot of pull in all kinds of directions, education, healthcare, infrastructure. All these are pulling in various directions on this income that we get from our taxes. Now, talking about the virus and impact on infrastructure, the CARES Act actually provided some relief. But ASCE continues to recommend at least an additional 37 billion for state DOTs, because a lot of the income for the DOTs has actually decreased significantly, and some of the work had to be stopped, and they need help. And so ASCE is pushing and trying to impact Congress to make that kind of money available, so we continue to have civil engineers having jobs and so on. So what else is ASCE doing? Well, we have the grand challenge, which is to try to decrease the costs of the life cycle costs of infrastructure by 50% by 2025. It's a very tough challenge, but you have to aim high, and even if we don't get there, I think the work that you, Habib, and your team are doing works in that direction. And I think that because basically the money that I just talked about, we cannot afford it. And only through innovation can we reduce the costs of this additional money that is needed to renew our infrastructure. So I really support the idea of these university transportation centers. The resilience, life cycle cost analysis, innovation, performance-based standards, all these pull in the same direction of trying to minimize the cost of our infrastructure. Also, talking about innovation, ASCE has a new student contest. The innovation contest is now open. The 2020 innovation contest national is now open, and the competition finals will be at the national convention at the end of October of this year. So any students listening, go to the website, Google innovation contest ASCE, and you'll find all the regulations to try to participate. We also have Future World Vision, which is it's like an you're trying to predict the future, and I think it's going to be we're trying to look at what's going to happen 50 years from now, what the world will look like, particularly cities. And long term, this is going to cost about between $10 and $15 million project, and we're trying to raise money to that effect. It's like an inverted time capsule, if you wish. We're predicting what would happen 50 years from now. So you know, 50 years from now, I'm not going to be around, but some of you, the younger folks, are going to be around. And so it's going to be interesting in 2070 for somebody to sit down and look at how ASCE future world vision compares to the reality. And it could be, oh my goodness, they were way off, or by golly, they were pretty darn close. So it's going to be, and that's an excitement and that I think is very valuable. And you know, the UTC probably looks at the future over a certain period of time. This is a 50-year look at the future. The ASCE has been really a big support for University Transportation Center, because we have a government division that interacts with Congress and tries to explain and advocate. So 2016, the University Transportation Centers got 72.5 million, and 17 was 75, 18 was 77. And last year, there was a significant jump to $96 million to support the work that you all do. I thought it was really cool. And Habib, I should have mentioned your name here. I'm sorry to put Jim Bryce under the bus here, but if you get a chance, go look at that YouTube site. And I think Habib, you showed the movie. That's mighty impressive thing. I think this is exciting and needed. I prepared this slide actually before the virus hit us, and it's a very good time to be a civil engineer. This is data from Texas A&M University. This is the percent of students having a job when they graduate. Now, the minute you graduate, you already have a job. If you're in other than engineering, the rate is 65%. If you're in engineering, it's 80%. If you're civil engineering, it's 95%. So even though those numbers probably dropped because of the virus, the order is probably still retained. And then new materials, you know, you're working on new materials. To me, it's in full development swing. Look at this, for example, a big airplane, not airplanes, it's not civil engineering, but still fatigue and material fatigue and things like this. This airplane, the Airbus 385, weighs about 200 tons. The weight of the passengers in it is 20%. If you look at the weight of the Golden Gate Bridge, it weighs 900,000 tons. If you load the deck with concrete trucks all the way through 6 lanes, it's 27,000 tons. So to carry 30,000 tons across the bay, we built something that's 30 times heavier. And so I think, again, composites, lighter material, all this is going in the right direction. Environmental protection and sustainability must be on our mind as we continue to develop new projects, because our planet is an egg. You know, most popular scientific thinking is that our planet is 4.5 billion years old, and it was very hot, and it still is at the center, but it's cooling down. And it's cool, as it's cooling down, the silica on the outside is forming rock plates. And so we have a shell which is about 100 kilometers thick, while the center is still liquid. 100 kilometers out of 6,400 kilometers. So, you know, we're walking on an egg, and we have to be extremely careful about our environment and sustainability. Explosion in transportation. Year 1000, horses. Year 1900, horses. Year 2000, cars, trains, airplanes, rockets. We went from the picture on the left to the picture on the right in 100 years. Tremendous technological explosion. Communications. Year 1000, messengers. Year 1800, messengers. You know, folks that ran and gave the news to the king on a piece of paper. Year 1900, telegraph, telephone. Year 2000, you know it. Overnight delivery, fax, computers, email, cell phone, social media. Tremendous explosion. And here, just look at the red band. You can't see the thing. This is a scientific knowledge as a function of time, going from 500 BC on the left to 2000 AD on the right. And you can see that from 500 BC to zero, there was a fair amount of scientific knowledge developed. You know, this was the time of the Roman Empire, Egypt, even Iraq, China. But then from about 200 AD to 1300 AD, wars were dominating the activities of our humankind. And then in 1400 or so, people say, well, it may not be a good idea to beat up on each other. And, you know, there's something else about life. And so that's the arts and the Renaissance. And then ever since that time, of course, we still have wars, but you know, the quality of life is something that's occupied our mind and has been the source of tremendous scientific knowledge development. And yet, you know, this is a little bit of bad news, obviously. You're looking at years of formal education on the left versus time, looking at 120 years here. Medicine has increased to 8 years. Law is at 7 years. Architecture, accounting, and yet civil engineering has gone down because we've decreased the number of credit hours that is required to get a formal education for a civil engineer. So, you know, something has to be done, and ASCE is working on this as well. Well, I didn't want to finish on a sad note, so I put those tremendous accomplishments of civil engineers, these high rises. When you think about it, and you think of those bridges, for example, you know, that really should make us proud to be civil engineers. Thank you for your attention.
Thank you very much.